Alright, we've got two forces P and Q, and we're just told the magnitude is P and Q, so we're not worried about direction here. So we know P and Q are both going to be positive because we're just looking at magnitude, so just be aware of that. So we know they're both going to be positive. So when it says when they're acting at 90 degrees to each other, so if we have P and Q here, and then the result is a force of 2√7. From that, we can tell that P squared plus Q squared has to be the square of 2√7, so 4 sevens are 28. So that can be our first equation. Now we're also told that when they act at 30 degrees to each other, now if I kind of draw a P and Q at 30 degrees, just remember we don't have direction, so this, we could say they're also acting at 150 degrees to each other. So just be careful here when we're looking at this equation. And some people kind of think, oh, I need to put a 90 degree in there. No, we don't know that, so we can't assume that. We do know the result is 2√13 though. So for that one, we'd have to use the cosine rule if we want an equation for it. So we'd get something like P squared plus Q squared minus 2PQ cos of. Now, we could either put 30 or 150. I'm going to just put which equals 2 times 2. So we've got 4 times 13 if I do that side squared. Something to note here is if I think of 4 times 13 here, I'm going to get 52, right? So let me just put 52 there. How am I going to get 52 when I know, first of all, I know P squared plus Q squared is 28. So I'm doing 28, take away something is a positive number. So you can see that the cos part's going to need to be negative in order for that to be 28 plus something equals 52. And I know that would be, so cos 30 is positive, but cos 150 is negative. So that'll take care of it. So that's why I'm going to use cos 150 there. All right. So what are we going to end up here with? That'll be end up being a plus PQ, and we know that cos 30 is √3 on 2 equals 52. So if I rearrange that, so 52 take away 28 is 24, and then I've lost my 2PQ, there's my 2, so that 2 is going to cancel there. So I'm going to end up with this equation that is PQ √3, I'll put it here, √3 PQs is equal to 24, so that means PQ is 24 on √3, or if you want to rationalize the denominator, we could say divide by 3, so 8√3. Alright, so that can be our second equation. Let's call that our second equation, and this can be our first equation. Alright, so really we're just doing simultaneous equations. Perhaps if I use this equation to get Q squared, I would be, so that was silly to square root, but anyway, so I'd be getting, I'll write it this way, so that's squared. And if I put that back into this equation here, I can find my p's first. So let's have a look. Get a bit of room going here. So subbing that into the first equation, we've got p squared plus, alright, so we're going to get 8 8 64 times 3 all on p squared. I'm just going to write it like that, because you know I'm a bit lazy with my calculator somewhere not handy. Alright, and that has to equal 28. So it looks like a quadratic in p squared if I multiply every term by p squared first. So multiply by p squared, but also bring that 28 over to this side. So 28p squared. And then my constant term will be 64/3, so 192. Alright, so you can use quadratic formula, or you can see, you might be able to see the factors. So 192, I need something close to each other. 16 and 12 would work. Minus 12 minus 16 I'm going to go with. Let's hope I'm right. Alright, that would give me p squared would be 12 or 16. Now we know, remember that p is just a magnitude, so we want a positive answer. So our p is either going to be root 12, which is 2 root 3, or root 16, which is 4. All right, since p is greater than 0. All right, let's put that back into we could put it doesn't matter which one we put it into. Actually, let's put it into 1. So if I put that into 1, I'm going to get q squared equals 28 minus p squared. So either minus 12 or 28 minus 16. So that's going to be a 16 and this is going to be a 12. All right, which makes sense. So our q is going to be root 16, which is 4, root 12, which is 2 root 3, since we know that q is positive. So you can see, I mean, we weren't told which one was longer. Which one had a greater magnitude, the p or the q. Basically, when p is 2 root 3, q is 4, and when p is 4, q is 2 root 3. So really, therefore, p and q are, with no order, they're going to be 2 root 3 and 4 in magnitude. Could be either way. All right.